Cloudera website where they have given you all the instructions on how the questions are going to come across. So this is what your entire blueprint looks like. Okay, so your questions would be coming up with 25% on infrastructure, 30% on data management, 25% on job mechanics, and then finally the query extraction from the data. That is you're extracting information. So infrastructure does get 25%. Okay, so the rest of the 75% is what is all your tools and all your development part would be falling into. So I'm just trying to see, I mean, if I have covered everything, each of the things here. So just trying to make a note of those stuff here. Okay, so what I'll do is today's session will work on this part. Okay, we'll make sure we finish it off, and then we'll start working on our development aspects. Okay, is it fine, guys? So a couple of things I just pointed out here is now understand the daemons. Okay, so recognize and identify Apache daemons and how they function in data storage and processing. Right. So what I said from the beginning is you always when you're trying to learn Hadoop, right? Just talk in terms of storage plus your processing part. Okay, so storage plus processing. Now I want you guys to help me come up with what is the storage components and what are all the processing components. Quickly type into the chat window so that I can type it here. So two components. Okay, so now what are the storage components? The storage is my Hadoop. So this is in generic. Okay, generic terminology. Now, if I say Hadoop, in Hadoop terminology, storage is what?
Hdfs.
That's right, exactly. Hdfs. And processing is what?
MapReduce.
Perfect. Is MapReduce. Right. Now, this is again in Hadoop terminology when I say Hadoop 1. Okay, this is all Hadoop 1. All right. Now there is Hadoop 2 also. We'll come to that in a short while. Now Hadoop 1. Now within Hdfs, what is Hdfs? What are the core components of Hdfs? Now storage, we're talking about Hdfs. So what are the components? What are the daemons? Right. So what are the daemons? Now you need to understand the daemons also. What are the daemons of Hdfs?
Name node and data node.
Name node plus data node. Okay, so always think in terms of master plus slave, right? Similarly, for your processing, master plus slave. Master is what?
Jobtracker. Task tracker.
Jobtracker plus task tracker. Perfect. So this is all with Hadoop 1. Okay, so you will also need to understand the differences. Okay, differences between Hadoop 1 and 2 as well. Now with Hadoop 2, your storage remains the same, exactly the same thing. Okay, the storage, there are no changes in the components here. But with Hadoop 2, okay, when you come to the processing part, a lot of things change here, right? A lot of things are changing here. What are the things here? What is the master called here? The master is called what? Okay, so you're processing, you're calling your MapReduce, you're calling it as
yarn,
right? Which is yet another resource negotiator. Okay, now within this you call it as the master is what? The master is resource manager plus the data, the slave part, the task tracker has been replaced with something called as node manager. right? So this is very, very important, guys. So try to understand the daemons, okay? Because your certification questions, they will also try to check your understanding of what are all the differences. See, basically, your MapReduce 1, your initial with Hadoop 1 is what is MR1, okay? Now, MR2, MR version 2, your now you can also say this as MR version 2, okay? So try to understand those differences. Now, with resource manager, okay, when this comes into picture, you would see that why is that? Now you need to understand why is that we are actually getting in resource management in resource manager into picture. What is the need for yarn? The need for yarn is with Hadoop 1, you will have overburdens on Jobtracker, right? Overburdens on Jobtracker. How is this? Overburden. Okay, I think the overburdened Jobtracker. How? Why is this, guys? Can anyone explain? Exactly, Balaji. See, we have a single master. Okay, there is single job tracker, right? Job tracker's responsibility is what? Okay, it needs to job. There is single job tracker, resource management, and RESO, job scheduling plus monitoring, right? That's right, Rakesh. See, now single thread to communicate with thousands of MapReduce tasks, right? So it's a single guy who is taking care of resource management, your job scheduling, apart from monitoring also, as well as monitoring. Now all this combined together is the responsibility of a single job tracker. Now what they're saying here is, instead of a single job tracker, segregate the resource management. If you actually go through the diagram, right, if you go through the presentation, in one of the diagrams we talked about the comparison between Hadoop 1 and 2, where you have resource management in between your on top of Hdfs, right? If you remember that, on top of Hdfs you have resource management. So that is where, okay, that is where the resource management part has been delegated to Yarn. Now, once Yarn has taken the resource management functionality, now you have the flexibility to run any kind of a job on your MapReduce, not just the MapReduce. Okay, you can run any kind of a program. Your streaming, your graphical processing, any kind of processing can be run. Now, until here we're done. Now we also understood, right? You also know the data, how data locality comes into picture, right? The data locality is what? Data locality is, see, I think I explained about on how the data will be split across multiple nodes, right? When you talked about rack awareness. In fact, rack awareness is a good thing where the block will be stored in different servers, right? So what data locality assumes is, what data locality means is, the job tracker will make sure, okay, whenever you are running a MapReduce program, the task tracker on the node where that particular block exists will be running. It's not that I mean, I have a server here. It's not that this server will be trying to do the processing on second server where this block is existing. Okay, the task tracker running on this machine itself will try to work on the block available here. So that is what the data locality is talking about. Now that's about on the daemons, various daemons, and what all the components. So guys, clear on all the daemons? Any questions with the daemons or anything? So with Yarn we'll go a little deeper. Okay, so we'll hear, okay, master slave architecture. Now within the node manager and within the resource manager you have other daemons. What are the two daemons here you are available? One is scheduler, not a daemon, processes you should say. Scheduler plus
App manager.
applications manager, exactly. Okay, and on your node manager, there will be one application master per application, right? There will be one application master per application plus all your daemons, okay, all your yarn childs. You call them as yarn child. Yarn child is nothing but your map or reduce process. Okay, so these are all the daemons which you need to understand. If you can understand what are all the daemons, what are the differences between these daemons, that is, that will really help you guys. Now, this is all about the differences between Hadoop 1 and 2. Okay, from a superficially, if you see these differences, this is all the differences. Now, if you go a little deeper, there are other major important features introduced with Hadoop 2. Right? So what are the important features? Why are we talking about Hadoop 2? The primary reason why we are talking about Hadoop 2 is because there are some issues with Hadoop 1. Right? With Hadoop 1, there is a single namespace. Right? You're having a single name node and then a single namespace. Namespace is nothing but a container. Okay, container which holds the metadata. A single name node and a single namespace, and here RAM is the limitation here. Now, how is this possible? I mean, what exactly is this? Because we are talking about Hadoop 1. I think if you see the diagram I have given here, it is not a good example, but this is Hadoop 1 and Hadoop 2. Okay, so yeah, let's say with Hadoop 1. So your name node RAM, right? The size of the your cluster is dependent on the size of your RAM. Now, if you step back and see, we have been talking about, I think I explained to you, right? So each file metadata would be occupying, each object would be occupying about 150 bytes of memory, and that 150 bytes of memory is what is being stored. Your metadata will be stored in two locations. One is on the disk, the second one is on the memory. And when you load this metadata into the memory, that's where the memory limitation comes into picture. So that is the primary reason why you cannot grow beyond maybe 4,000 nodes in a cluster. Okay, 4,000 max nodes in Hadoop 1. Right? Now that is one of the important limitation here, where you have a single name node and a single namespace, and RAM is a limitation here. Now, name node is a single point of failure, right? So what is the single point of failure? It's a single name node, right? In case your name node crashes, we talked about checkpointing earlier, right? We talked about checkpointing, where in case your name node crashes, then you need to restart your secondary name node, pick up the metadata from there, right?
It's like it's not a hot standby.
Exactly, that's right. Right. So with Hadoop 1, you have where is the diagram? Okay, we talked about this part, right? Checkpointing part, I think you guys understood, where we talked about name node and secondary name node, where name node is a single point of failure. Secondary name node only contacts name node every 1 hour and picks up the metadata. And in case this crashes, your cluster is down till the time you take action. Okay, your administrator comes into picture and brings it up. So that limitation has been overcome with Hadoop 2. Now, single job tracker, we already talked about this. This guy is responsible for resource management, job scheduling, and monitoring. Now, you will see when you start writing your MapReduce programs, you will see that if a particular task tracker is not completing a job on time, what will happen? It will, if say for example, a task tracker does not have enough resources and it has died down. Now, it is the responsibility of the job tracker to make sure that task tracker is invoked on a different node which has a similar block, right? All that we have seen, right, previously. Now, single job tracker, and only MapReduce framework to process the data, right? So these are all the features as well as limitations, I would say. Limitations of Hadoop 1. Now with Hadoop 2, now single name node limitation is overcome by the feature federation. Did we talk about federation, guys? I don't think so.
No, Kumar.
No, we not talked about federation, right? So what is this federation is? Federation is, okay, federation is not HA, okay, don't confuse federation with HA. HA is different and federation is different. That's why I put it two separate points here. Federation is having multiple name nodes. Okay, having multiple name nodes is the concept of federation. Okay, so what will happen is, see, if you have one name node, you can have maximum of 4,000 nodes. Now, once you hit the 4,000 nodes or once you hit the name nodes RAM capacity, what you need to do, you either go for a new cluster, you go for a entire new building up a new cluster where it will have its own name node. Now, instead of building a new cluster, if you step back and see, what we have been saying is the more number of nodes you have in a cluster, the faster the processing would be. So instead of building a new cluster, okay, add the same name node to the existing cluster. So that feature is not implemented with Hadoop 1. With Hadoop 2, they have found out this is a great advantage. So with Hadoop 2, they have implemented this process, and that process is called as a federation. Now, if I add two name nodes, this is for a single one. If I have two name nodes, I can expand the cluster to 8,000 nodes. If I have three name nodes, I can expand the cluster to about 12,000 nodes. So that is providing you to store more amount of data on a single cluster, and also when the more data is there and more number of nodes are there, your processing will be faster, right? The same analogy, you remember we have been talking about distributed systems analogy. One person doing one job in 10 minutes and then 10 people doing the same job in 1 minute. The same analogy can be applied here. So always the more number of nodes you have, okay, the more number of nodes you have, the faster the performance would be. Now this is what the federation is. Federation is a feature of having multiple name nodes. Okay, now say for example in your organization there is a development team, then there is a marketing team. Okay, development team, marketing team, and there is a sales team or a finance team. Right, finance team. So what you can do here is with Hadoop 1, everybody goes to via single name node, right? With Hadoop 1, everybody will be going via single name node, and three different teams are using the cluster to run their MapReduce program to upload the data into the cluster, right? Now, once if the name node is down, okay, your entire department, the entire organization is sitting idle till the name node is come back up, because you will not be able to run any MapReduce programs until the cluster is back up. But with federation, what you can do is you can have multiple name nodes, okay, dedicated to each of the departments, okay, dedicated to each of the departments, and when the name nodes are dedicated, your department will go only via that particular name node. So if one name node is down, only development name node is down, only development guys will be down. So your marketing team and your finance team are still good, right? Your marketing and finance will not be affected. But that is not the case with Hadoop 1. If the name node is down, the entire organization is down. So this is a primary advantage here. Now another important thing with federation is you need to understand that the name nodes do not talk to each other. Okay, the name nodes do not talk to each other, but the data nodes will know the data nodes will be aware of all the name nodes, because the data nodes will hold the data. See, the data node's responsibility is what it will be holding the block information. Now the data nodes do not know what this block is on, what this block, to which file this block belongs to, right? It just acts as a storage, and it accepts the block file. That's all. So So they'll just be accepting all the blocks, and then one other important thing you need to talk is block pool report. Okay, so the data nodes will be sending in block pool report. You need to introduce here something called as a block pool report. So what is this block pool report? Block pool report is data nodes will publish a list of blocks available to the name node. Okay, so this is what is a block pool report. Okay, we'll not a publish, I would say. We'll give the list of blocks available to the name node, right? So this is a block pool report. Guys, clear with federation? Okay, now federation. Then the other one is role of MapReduce. We have seen analyze benefits of challenges, default replication values, storage requirements, determine how Hdfs stores, reads and write files, how streaming might affect our job workflow. Okay, now HA is another feature, high availability. Now with Hadoop 1, if the name node crashes, your entire cluster is down. But with Hadoop 2, they introduced the concept of HA, where your secondary name node is replaced with standby name node. Okay, you're not talking about secondary name node. You're talking about standby name node. Okay, standby name node is what? Standby name node and active name node is what we talk about. Okay, standby name node will have. Okay, so here this will provide automatic failover. This will provide automatic failover in case of name node crash. We're not seeing this diagram, right? Say standby name node. I think I've not introduced to you guys. So we have standby here. No, we're not talking about H. So okay, let me put that here quickly. So we'll finish off with this theoretical part, and then we'll go directly. I mean, with tomorrow's session, we'll go into development. So let's say you're implementing HA. So you have your name node. This is your standby name node. So always the configuration is all the same. Anyway, you don't need to worry about that on the configuration part. Okay, name node and your standby, and then I'm just saying so that it's a standby name node. Okay, now what you can do here is let me put it here. And your data nodes are all. So I'll tell you what this diagram is all about. Say I have 4 nodes in this. Oh, this is the wrong place to keep it here actually. I should keep it here somewhere. Oh, okay, let me keep it here. Let me drag this a little bit this side. Drag this a little bit this side. Okay, so these are all my data nodes. DN, Now we are talking about Hdfs. Okay, we're talking about only Hdfs. I'm not still gone to Jobtracker or map this part. Okay, so this is my entire cluster. Okay, the important thing what we are talking about is Hdfs HA. This talks about Hdfs HA. Now, if you see with Hadoop 1, okay, with Hadoop 1, if you look at here, the communication on how the communication happens. Just visualize this diagram, okay? So your name node, secondary name node, and your data nodes. Now come back and see here how the communication will change here, right? The communication will be and also to the standby node. Okay, now this is where the shared NFS, I would say. Shared edits. Basically, all this is not required from a developer. So, I mean, nobody tells all this for the developer perspective, but good to know these things. I mean, if you're aiming for certification. Okay, shared edits is where your metadata, your edits logs will be written on here. Okay. Now, if you see the differences, can you spot the exact difference here? So this is Hadoop 1, okay, and this is your Hadoop 2. Can you tell me what is the primary difference here? What is a major difference between, if you want, I think
both connected to standby and main node.
Exactly, that's right. Perfect. So if you see the communication here, right? See, with Hadoop 1, the data nodes know only the name node location. Okay, data nodes know only the name node location. So what will happen here is, in case this name node crashes, they are not aware of secondary name node. So that is why we have to rename the secondary name node as the name node and change the IP address. Because in the configuration, if you have seen the configuration right in your core site XML, you are defining only one host name where your default fs.default fs is being residing, right? So that is the only, they know only, and they are capable of sending in heartbeat message only to the name node. Now with Hadoop 2, when they implemented HA feature, okay, they need to make sure that the data nodes know the location of both the name nodes, your active name node as well as your standby node, right? So the data nodes will be sending in heartbeat messages to both these guys. Now there's a problem here. If these are sending heartbeat messages, they'll be sending in the block pool report also. And the block pool report, right? So the metadata, only one guy should be writing in here. So your metadata is in two locations, right? One is an FS image, the second one is edits log file. The edits log file, if both these guys start writing into edits log file, this gets corrupted. So what they have done is only one guy will be writing in here. The second guy will be reading the edits log file. So it will read the edits log file here and then applies to its own namespace. Okay. So though they get both of them get the heartbeat messages, only one guy will be writing into the shared edits. The second guy will be reading from here. All right. So in case now in case the name node crashes, okay, name node crashes, you don't need to do any manual intervention. You can simply go ahead and bring up the active, I mean the name node instance on the standby server, and there is no chance of losing any metadata because all the incremental addition is being written onto a shared location. So this is actually outside the cluster, right? This is an NFS. You can say it as an NFS. Right, it's an NFS. NFS you might be aware, right? What is NFS? It's a filer, right? So filer where you'll have a shared storage. Guys, clear with this? Okay, so that is what is your HA is talking about. Now, this will provide automatic failover. Now, this is actually a manual failover. Now, you need to talk about something called as a Zookeeper. Zookeeper will provide. Zookeeper is what? Is a Zookeeper. I'm not sure if you heard of it, but Zookeeper is utility. Is actually an open source. I'll say it's an open source application again from Apache. Okay, so this will provide Zookeeper will provide coordination service for distributed systems. All right. So Zookeeper is what it will help you to coordinate between HA, right? So when you say when you want to implement automatic failover, you can use Zookeeper to make sure if this crashes, it will automatically be failed over to your standby name node. What are all the important features and differences? Thinking what else can be covered from a features perspective. Analyze how Hdfs implements files, blocks, and block abstraction. This you should be aware, right? So you are talking about it is talking about block size. Block size is what? Block size is 64 MB. Okay, default block size, and then replication. Replication is 3x replication. Always make sure the replication factor is the number of nodes in your cluster are greater than your default replication. Then what else we are talking about? Determine how Hdfs stores reads and write files. This we have seen read anatomy and write anatomy, right? Clear with that? Read anatomy and write anatomy. You remember we talked about this part when we did the presentation, read anatomy and write anatomy. So read and write. So write is within write. Okay, Hdfs write, right? So within Hdfs write, what we talk about is write is what, and replication is what, guys? I think I told you. Write is what? Write is parallel. Exactly. Replication is sequential. Perfect. Okay, so this and all talks about write and read and write. So write is parallel and replication is sequential. Now, what else is there? Identify the role of Apache Hadoop classes, interface methods. This we'll see anyway. Understand streaming might apply to job workflow. So streaming is something which there are some streaming packages available which will assist you to actually. Let me bring it up and start the instances here. So if you're a non-Java programmer, you can use streaming APIs, okay, streaming to run a MapReduce program, which will convert your non-Java program into a MapReduce program. So,
Kumar, I have a quick question here. When I try to open the Cloudera manager, actually it's not opening. It's like taking so much time.
Right. So what I would suggest is go here and check the memory settings. Okay. So
okay.
Your system, just keep it 4 GB RAM. Not
okay.
sure. I think it's maybe if
I think it supports 8 GB. It was mentioning like 8 GB is required.
That requires 8 GB, but then depends on your machine capacity also. What is your RAM on your machine?
It's 6 GB.
6 GB. So that will be a problem, right? So make sure you give it to 4. See, mine itself is 8 GB, so I've just given it 4 GB, but still I have issues when everything comes up.
Okay.
Okay. So so keep it, stick it. See, what will happen is your Windows is is it a Windows or it's a Mac?
Yeah, it's a Windows.
Windows has it requires a bigger footprint when compared to your Mac. Okay, so Mac doesn't require so much RAM. See, I'm taking 4 GB here. I'm allocated 4 GB for my Cloudera instance here, and it has taken 2.2 GB for Windows itself. 2 GB is required for your Windows operating system. Okay, so that is not the case with Mac. Mac will take only, I think, less than 1 GB for the operating system. So make sure you look at the memory usage here. Okay. So I think I've not shown you this part, right? When you logged in previously, I was having some issues and then we could not connect. So you log into the Cloudera Manager here. Okay. So basically, when you have access to the Cloudera Manager, so you launch a terminal. See, this has got everything. It has got Eclipse also in here. So launch the terminal and try your basic commands. Okay, I think that's what I was telling you before we break last week on Thursday, I think, right? So come on. So some of the things you can actually look at here is we already have a data sets available here. Okay, a lot of data sets are available because some of the data sets we can use for our MapReduce programs. Then workspace, just make sure you download this and keep it up. For training, default stubs are available here. Okay, these stubs I think I showed you last time, where you can test out the your mapper program, your reducer program, and the primary driver program, and then your test. Okay, this is only to test out the Java program, right? Your whatever program you're going to write. That is something which I want to show you guys. Then coming back to Cloudera Manager, you as a developer would not be using much of admin parts, okay, but here is where you can see here is where if you want to actually verify your Hdfs part, right? So Hdfs, go to Hdfs, but I'd say play around with this GUI. Come on. Okay, so basically your name node UI is what I would be more interested in. Right, your name node UI. So this is available on port 50070. Okay, so you can see this the information about what is running on the capacity, the configured capacity, everything on here, and how many servers are available for me. All this can be viewed from this interface. Okay, and if you actually look into so your configuration files are under here, etc, Cloudera, SCM, so if you want to verify that, right, so pipe grep for name node, just verify. These are all Linux commands, okay, ps-ef, these are all. I think I did tell you to play around with this, right? Yes, did you guys get a chance to work on your Linux skills? That's what I remember telling you guys in the last session.
I've just installed today, so I'll start working on those commands and everything. I installed this with the help of Daniel, so I'll start doing it.
So you're doing EC2 instance, huh?
Yeah, EC2 instance, yes.
Okay, perfect. All right then. Okay, so opening files to Hdfs. Okay, so if you have worked with Linux, then no problem, guys. So you should know. You're already on the right track. Okay, so because from a development perspective, basic Linux commands are good because see, you need to understand how to load the data. Okay, only just need to load the data, then open the files and all, right? So basic commands is enough. What else I can show you right now? Here is other navigation. I think we have seen one MapReduce program the last week, right? So let me go ahead and show you the Jobtracker also. So the Jobtracker, here is where your Jobtracker user interface, which is useful for you guys. So these interfaces, right, which is your name node UI and your Jobtracker UI is what you typically be using. Okay, because you will not be given access to the cluster, you will only be given access to the client machine. From the client, you should be able to connect. So now that because you have access to the client, the moment you run a MapReduce job here, you can see the status in this location. Let me go back here and see if I have yarn. I think yarn I have still not started, because if I start yarn, it will take a lot of process again. Yeah, there you go. So I have started only MapReduce and yarn is down. Okay, so if you're starting yarn, right, it will indicate that MapReduce is not required. Okay, so yeah, Zookeeper is here. So I'm just starting with MapReduce only. Now the program that we ran, I think, was from user lib, right? So Hadoop-MapReduce. So this examples jar file is what we have written, we have executed last time. Now if I see some of the commands, basic commands, I have asked you to play around with querying the file system, right? Like how can you upload the file? So Hdfs, DFS, since you don't know what commands you can execute, you can just hit enter here. It will tell you, it will give you a listing of all the commands that you can execute. Now Hdfs DFS -ls. Okay, ls is something which will tell you what is the directories available here. So always make sure the distinction between the local file system commands and the Hdfs commands. Okay, the commands that you execute on a local file system. If I say ls here, ls, I am on this particular directory. Okay, so ls is giving me the information on this local file system. But this ls, what I have done here is actually on my Hdfs, right? This is actually on my Hdfs. So if I see, if I want to see, I mean, you as a developer do not even need to execute those commands, but good to have. You can directly browse the system with your browse the file system from your name node UI interface itself. You can actually browse the file system. So here is where all the information is available for you. See, last time, I think last week we logged in with the user Cloudera, and then we ran the MapReduce program, and then we saw the we saw the output getting created here, right? So similarly, this is how you can navigate around around your user interface or around your name node UI. Now, if you want me to quickly run a MapReduce program and also show you here, let's run the same program. What is this? Right, this is the program which we ran the other day, right? So Hadoop jar. So this is how you are invoking the program Hadoop. Okay, jar file I'm sending it here, and then if you are using a streaming, you will be sending in the streaming in here. Okay, and then word count on test.txt. Now if I hit enter, see, I already have this user Cloudera output created, right? In my Hdfs, come on, user Cloudera output is already created. Now if I hit enter, will it work? I'm hitting enter. Quickly, guys, will this work? Yes, no, don't know.
Yes. I mean, if
Ah,
you go
okay.
into that the output would just get display in test.u.
Right. See, we already have the output directory. Okay. We already have the output directory. So, okay, let's see. Let's see. Why is this taking so much time? See, what it says here is, okay, what it says here is this output already exists. Okay, that is one of the important Hadoop, one of the very, very important thing with Hadoop. Hadoop is write once, read multiple times. Okay, you write once and read multiple times. You're writing, you can see there's no question of overwriting here with Hadoop. You can append to a file, but you cannot overwrite. Because see, the output is already existing in here, so you cannot override this output directory. So what I need to do in case if I want to run the same program again, I just increment it here. Or basically I give a date timestamp, right? So you can give $date, just append the date timestamp there. So this is important from a development perspective because you will not be able to run the same program again. Well, not the same program. The output has to change every time you run the program. Okay. So if appending a date timestamp, or will definitely append the timestamp into your output directory. So that way you will be able to execute it multiple times. So if I say output 1 here, or increment the output directory, or maybe that's how you can plan actually. So that's very, very core important thing, guys. Important to remember always. Hadoop is write once, read multiple times. Yeah, my machine is obviously slow as usual. Now you see this has started creating the the input paths and all. Okay, so we'll talk about input paths when we talk about programming. So total input paths to process is 1. Okay, that is talking about only one block. My file is a very small file, so only one block is coming. Now I have a job running here. I have a job ID created. Now how do I see the job status? If I come back into my MapReduce GUI, which runs on port 50030, that is my job tracker. Right, I just go and refresh here. Okay, my map is 0%, reduce is 0%. Come on, this refresh is also taking so much time. Okay, there you go. So I have a schedule. I have one job. Come on. Okay, I have one map task running right now. Okay, so this job is running right now. If I refresh one more time. I think it's stuck here. Just let me see. Oh, what's happening? Why is this not executing? There you go. Now it is under running jobs. Okay, earlier it was blank here. Now it is running jobs, and then my my map is 100% complete. Okay, my initial mapping is done now, and now my reduce will pick up. Right, reducer will start now. So here, if you refresh again here, come on. See. Right, here is where you see the mapper is complete 100% and reduce is complete. Reduce is getting complete. See, you would typically be having access to this part, okay? But if you want to see what's happened after you run a couple of jobs, you can always come and keep a track of them from your Jobtracker GUI. Now reduce is also complete now. Okay. Now what's happening here is right now it is cleaning up the data. Okay. Now you've done a mapper. Once the output from mapper is sent to as an input to the reducer. Okay. Now reducer is also working on the input sent to it. Now this temporary data where it is given, that temporary data is all being wiped out. Okay, that is why it's taking so much time. So once this is done, right, your output will be created in the directory by the name output1, right? The same output what we have earlier executed. See, this is basically we are doing a word count program, and that is we are doing it on test.txt. So your program is complete, right? Your job is complete. This is your job ID. Okay, this is your job ID, and it has a launched number of tasks, 1 task and 1 reduced task. So now here is where you will see, come back in here. Now it was under running jobs. Okay, this is under running jobs. Come back and refresh this. In the meanwhile, I'll share you the link which is about talking about certification preparation. Just go through this. This is really helpful, guys. Okay, now the job has moved from running state to complete state. Now, if there are jobs which have failed, right, which has failed or retired, in the sense if they're running for a long time, you'll be available under your retired jobs or failed jobs. Okay, so this is indicating my job is complete 100%, my mapper is complete, and my reducer is also complete 100%. So what I want you guys to do is, as an activity, I want you to run a simple MapReduce program. Okay, by tomorrow's session, just write the MapReduce, run the MapReduce program. Now you know how to run the program. Right? This is upload one file. Now you know how to upload files. Now you can execute Hdfs commands. Well, that's the expectation, guys. You are supposed to know, I mean, what are all the daemons, then how you can play around, how you can upload files, how you can upload files, how you can read the files, and how you can execute. Given a sample program, how you can execute it. So everybody, I want you guys to execute this MapReduce examples jar file, okay, before tomorrow's session or whenever possible. So make sure you execute this, and I mean, just try to I just want you to see what is the output here, okay. And then once we do a deeper dive into MapReduce, you'll get to know what exactly is happening. So as a practical step, I want you guys to work on these aspects. So how many of you are going with EC2 and how many of you are going with Cloudera instance?
Kumar, we'll try once again with EC2, but I'm not sure why that format didn't happen properly, but I'll try to do it by creating a new instance.
Right. See, in case you are getting into issues, right, what I would suggest is always come to the blog, right? So the blog which, the side blog, where is that? The link, you should have the link, right?
Yeah, we have
So
the link for the classroom blog.
In the classroom blog, please update and go and update there, and then just shoot an email so that we can I mean, I can get back to you with what is the problem there and what would be the solution.
Okay.
So I mean, if you're just stuck there, right? I mean, I would not be aware. So if you had you reached to Daniel or me, we could have helped you to fix it. But yeah,
okay.
But going forward, just update there so that you're not stuck there and you're not waiting until the next session.
Yeah. Okay.
And Kumar, one question from my side, like for the EC2 which I've done, right now if we check all the Java, whether it's installed or not, and even the Hadoop, and if it's not there, I have to go ahead and install those and then come over here to run the program, right?
Right. See, yes. See, when you launch EC2 instance, there's a plain operating system. Nothing comes with it. So you need to install Java, and then you need to install all the packages. So the spreadsheet which is available here on your blog site is what will assist you to it just goes. Guys, can you hear me? Oops, one second. What happened? Can you hear me? Is it any better? Hey guys, can you hear me? Nirmal, can you hear me? Okay. Yeah. So, see, when you launch EC2 instance, see, this Cloudera Quickstart, right? The Quickstart VM will give you everything to you on a platter. Okay, everything is installed on this. You don't need to worry about installation and all. But if you're sticking to EC2,
sorry, Kumar, I didn't get that.
okay, so what I was saying here is, see, if you go with the Cloudera VM box, everything will be installed to you. Okay, everything is installed on it. You simply go to that particular location and then start uploading the files and running your MapReduce programs. Okay, because when you launch your Cloudera manager, it will start all the instances for you. But EC2 is a different instance case where you need to do everything from the scratch. Okay, you need to install Java. Okay, your JDK should be installed. Then you need to install your all your program, all your packages, your name node, your data node, your resource manager, your node manager. All the packages needs to be installed one after another, and then you format the cluster. Only then you will be able to start uploading files and executing any MapReduce programs.
Okay, got it. Yeah. Then this should be easier, I think. Then I'll try to download Cloudera.
Right. You can download Cloudera and play around with this. I mean, if you want to get kind of more experience on the admin side, maybe later at some point of time you can go with the EC2 instance. But initially you can stick with this. But only catch here is yes, Birbal, go ahead.
I'm sorry. I mean, my only concern is that my laptop configuration for RAM is like only 4 GB. So for Cloudera, you were saying that minimum of 4 GB should be there. So reason why I was going with EC2.
Right. In that case, don't use this. Okay, you'll not be able to attempt anything if you have only 4 GB. So I would suggest you go with EC2 only.
Okay.
Okay, because Sapta himself has about 6 GB and it is not allowing to work on, because so that's a problem. So don't go with the local instance. Just go with the EC2 instance. Install an EC2 instance. I mean, I can help you, right? I mean, if you're having issues, right? So you can collaborate. So if you put it on the blog post, we can guide you where you're stuck, what problem you're getting, so we can get you to the place where you will be able to execute your programs.
Okay, yeah, sure.